9.3, from vertex to general form. So in 9.1 and 9.2, Miss Atwood told us about general form of quadratics, which looked like y equals ax squared plus bx plus c, where a could not equal 0. Okay? And then we learned about vertex form, when we had y equals a times the quantity x minus h squared plus k, where hk gave us our vertex. Okay, moving on, we're going to talk about how to go from one form to another and how to manipulate our variables and terms and whatnot to do so. Starting off with some vocabulary, I mentioned term already. A term is an algebraic expression that represents only multiplication and division between variables and constants. So we have a polynomial here, x cubed minus 6x squared plus 9. The terms individually are x cubed, 6x squared, and 9. Okay? Only the multiplication, if we had 1/4, or like this was x divided by 4, that would also be a term, or x squared divided by 4. That would be a term as well. It's only multiplication and division. A polynomial is the sum of terms that have positive integral. A polynomial is a sum of terms that have positive integer exponents. For example, x to the positive 3, x cubed minus 6x squared plus 9 is a polynomial. All of them added together is a polynomial. The only requirement here is that these exponents be positive. Okay? Classifying polynomials. We're going to do some work on classifying polynomials because there can be different kinds. We can classify them in a couple of ways. We can classify them by the number of terms that they have. Monomials have one term. So this would be x squared or 2x cubed or something like that. Binomials have two terms, x squared or plus 4x. That would be a binomial. Trinomials have three terms. That might be 2x cubed plus x squared plus 4x. Okay, just an example there of a trinomial. All of these are polynomials, poly meaning many, and if we get into more than three terms, then we just say polynomials. We don't really classify them any higher than that, although you can. We also classify by degree. We've already looked at linear equations, or linear expressions would be something like x plus 4 or 10x plus 9, okay, where the highest exponent is 1. Okay. Quadratics, the highest exponent is 2, so x squared plus 8 or 3x squared plus 7. Highest exponent 2. And then cubic is highest exponent of 3, so x cubed plus 3x squared minus 10 would be a cubic expression. So we're going to do some practice with that. If we were to classify each of these polynomials by its terms and degree, this one has 1, 2, 3 terms, and the highest exponent is 2. So we have 3 terms, trinomial, highest exponent is 2, quadratic. We have a quadratic trinomial. Here we have 2 terms, and the highest exponent is 1, so this is going to be a linear binomial. And for class, I will let you classify this third polynomial. Moving on, we're now asked to add and subtract these polynomials. It is more difficult, or people have more mistakes when subtracting polynomials because we have to distribute the negative. Okay, we have a negative out here, and we're just going to take this quantity minus this quantity using like terms. We have a negative out here. There's a couple ways we can do this. We can go term by term or we can distribute the negative and then subtract, or then simplify. So I'm going to show both ways. If we're going to go term by term, we just got to go highest exponent to lowest. So we have x cubed, 7 minus, or 8x cubed minus 7x cubed will give us 1x cubed. Okay, we have no x squares in this first one, so I'm going to just assume that just write that we have 0x squared minus a positive 3x squared is going to give us negative 3x squared. 4x's minus negative 15x's is going to give us a positive 19x. And then 10 minus a negative 30 gives us positive 40. That's one way to do it, term by term, just like term by like term. Notice that I kept subtracting whatever was inside these parentheses. Okay? If we go the other way and we distribute the negative, then I'm just going to rewrite out what we have. We have 8x cubed plus 4x plus 10, and then I'm going to distribute this negative. Negative 7x cubed, negative 3x squared. This will turn us positive 15x. A negative and a negative is positive. And positive 30. Okay, and then I'm going to simplify by adding like terms. Positive 8x cubed and negative 8x, or 7x cubed is 1x cubed again. We only have one term of x squared, so we have a negative 3x squared. We have 4x and, oops, this was supposed to be an x, 15x, so that's 19x. And we have 10 and 30, so that's 40. So again, we have the same amount, or the same simplified answer there. Okay. Adding is a little easier because you really don't have to distribute anything. You can just go term by term or simplify as is, as if the parentheses were not even there. Keep in mind, we go highest exponent to lowest. Okay, so our x cubed is here first because 3 is our highest exponent, then to 2, then to 1, then to 0. So try that in red for class, and we will move on to multiplying polynomials. Multiplying polynomials is just using the distributive property. We've used it before. We have posters in the room, the kiss your parentheses goodbye. We're just going to take what's on the outside and swoop it in to the inside. Okay? So here we have 5x times x. If you want to, we can write that out. This is going to be 5x times x minus 5x times 7. Okay? Or if you want to just do it right away, 5x times x is going to be 5x squared. 5x times a negative 7 is going to be a negative 35x. And then we cannot reduce anymore because we don't have like terms. Moving on to the 3, we're going to distribute this 3 inside each term inside the parentheses. So we are going to have 3 times x squared is going to give us 3x squared. 3 times 7x is going to give us 21x. And 3 times a negative 10 is going to give us negative 30. For class, try your best to distribute this negative, or this 2x squared into the quantity 3x plus 4.